Good morning or afternoon, wherever you are. My name is Shaun McCullough. I'm really excited that you are here to join us in our workshop this morning as part of our ongoing series about attacking and detecting in our cloud environments. Just a couple quick things about the workshop, and then we'll kind of get into it. Um, First of all, I put a question in the Discord. Please come join us in Discord. That's the best place to go and ask questions while I'm talking or even during the labs. Um, if you go to the URL, it's on the screen, the aviata.cloud. On that page, there's a chapter 4. There's a link to the Discord to go and get into the Discord. Come and join us. That is our best place for having that engagement. One thing I did ask was, what is your favorite cloud? I was kind of going for like, what is your favorite cloud in terms of like, cloud security, like AWS, Azure, Alibaba. Of course, Ben's is Cumulus, so that thank you for that. Or Cumulumbus. I don't even know what that is, Ben. So good. So let me know which cloud that you're using in your environment. That always helps because in our conversation, if most are using Azure, we can do some translation as we talk through this workshop. So a couple of things about logistics for workshops. Um, the way this workshop's going to happen is I'm going to do a little bit of talking and then turn you loose for a 30-minute lab. Then I'll come back and we'll do a little bit of talking and then turn you loose for another part of a lab, and et cetera. We'll go through that, build 3 different lab sections. This is your workshop, so you can just run through the labs if you feel like it. That works best for you. Or you can just hang out and listen and then do the labs later. It's fine. There's nothing the information will be all available for you. On this page, on the aviata.cloud, there's a section called Chapter 4, and in there is some links to the different parts of what we're doing today with a rough estimate on time frame. Don't hold me to that time frame, but there's a getting started. And then that is the biggest thing. So a couple of things you need to do for this workshop is you need to have Firefox. You need to have an AWS account that you have control over. And then you also need to download and install a proxy extension for your Firefox that would allow us to interact with a particular service that we're standing up in the web environment so that we can do our attacks and detects in a protected environment. So Ben has done an amazing job of writing up detailed instructions for how to do it. That's part of our getting started. We actually will allow for time for doing that, and I'll talk about that in a second when we get to it. But just wanted to give you a heads up of like some of the prerequisites for this class. Or not class, I'm sorry, for this workshop. I do want to mention that this workshop was not written entirely by me. We have other awesome people like Ryan and Eric, both SANS instructors, who did a lot of the presentations for other stuff, and I pulled it together. But especially for Ben Allen, who has built a lot of the backend infrastructure for this, did a lot of the testing, and is going to be our TA for today. So Ben is hanging out in Discord. If you have questions about the lab sections or the installation or stuff, Ben is a great person to reach out to in Discord. Just say, hey, I need some help. Ben should be able to help you with that. All right. All right. Enough of that. Let's get started. Just real quick about me. My day job is I'm a cloud security architect with GitHub. My current focus is on running our cloud, what we call cloud fundamentals, which is really about posture management of our cloud infrastructure. I've been there for a little over 2 years, and I'm loving it. My other job is I'm a co-author for the SEC 541, which is the cloud security threat detection class. I love doing that with Ryan Nicholson. So if you like this workshop and the way it's laid out, this is really what our class is, which is we do some attacks, and then our focus is how do you detect these attacks inside a cloud environment. Before all that, I spent 20 years in the National Security Agency doing a whole bunch of stuff: software development management, technical director, Blue, Red, and Hunt leads. So had a big career there. If you ever want to say hi, LinkedIn is actually the best place to jump in and say hi to me, and would love to respond. So some people tell me what cloud they like, and you're saying Azure, which is interesting. I will say I've been teaching SANS classes since 2018, I think, and for cloud. And at the beginning, it was like all AWS and like one Azure person. And now when I ask the class, it's like half and half AWS and Azure. And most of those people are in both. Like it's not because they have one or the other. There's always a couple people in GCP. More and more people are in GCP. Always get a couple of oracles sometimes throughout the year. So let me know what cloud you're in. Be interested to hear on that. All right, just a real quick rundown of what we're going to be doing today. I just did my introductions, so we're done with that. Uh, we're going to be talking about Kubernetes. That's what the attacks are. We're going to be attacking a Kubernetes cluster that we're going to spin up in our AWS environment for the purpose of learning about some of the log and telemetry data that we have access to understand if someone is attacking or doing an investigation. So detection is an investigation always kind of go hand in hand when we start doing our pursuit inside of our cloud environments. And so we can't talk about one without the other because it's the same telemetry usually that we're pulling. So I look at a Discord, is it Joom? It's J, two eyeballs, and M. I love it. You have them all. So that's funny. Yeah, I have all the clouds. We just have every one of them. Yeah. So I'm gonna guess you're like a service provider or something. Usually they have all of them. Or you're a large company that has bought other companies. So that tends to be what happens. If you're a big company and you're like in Azure, and then all the companies you buy are in AWS, guess what? You're in two clouds. So oh, instant response. Oh, okay. All right, great. Thanks for joining. So we're going to be talking about Kubernetes and Kubernetes threat matrix. If you want a deep dive on how to stand up Kubernetes, chapter 3 of this series that we're doing of workshops is great because we walk through exactly how Kubernetes works and how we build it. We're going to make an assumption that you understand Kubernetes enough. You don't have to be an expert on it, but we understand maybe have some experience in Kubernetes. Once I talk about the threat matrix, I'm going to turn you loose for about 20 minutes, I think, 20, 30 minutes to build the environment. So the environment is Terraform after you get your proxy set up, and two different places we run Terraform. And so what we'll do is just make sure you kick off the second Terraform, and then you can come back and we'll do that. After that, we're going to do a section real quick on attacking Kubernetes. We'll talk about some of the ways that attackers are going after and have a conversation about like what's the best method to do that. And then we'll do a lab on where you will attack your Kubernetes environment. And then we'll come back and we'll talk about detections. And then I'll turn you loose for the final detections discussion, or no, sorry, discussion, but lab. And then I'll finish up with a conclusion. All right. All right, one second. My Siri is going crazy. It's talking to me. All right. So we're talking Kubernetes. Kubernetes is like, well, okay, let's rephrase. We're probably moving more and more into the cloud. You're here, so you're probably very much into the cloud. And then we're moving more of our infrastructure and our applications out of VMs and into something else. I tend to find that if you're in Azure, like you're all in Kubernetes, like you're just like everything's a container. I can run things on-prem as I can in the cloud, and it works really well for you. If you're in AWS, I feel like people are like, I'm just going to rewrite everything in Lambdas and all kinds of event-driven. You're a little bit more up for doing that. But most of you are probably in a large organization. You're probably doing a fair amount of like lift and shift, or you're not completely rewriting all your code to move into the cloud. Kubernetes is a really great way to do that because it works kind of the way it works in your on-prem environment, with some nuances, of course, from an operational standpoint. But from an application standpoint, as the app developers are building apps, it looks very much the same. Now, you can roll your own Kubernetes infrastructure, which we did in the lab in chapter 3 of this series. But I'll be honest with you, I feel like the best option is to use the cloud environments managed service. A couple of different reasons. One is because they make some decisions on security for you, or make it at least easier for you implementing some of the security things. The other thing is that you're interacting with the cloud environment through the management API for building that infrastructure and some major changes. And so whereas before, everything's happening on a VM, the cloud environment has no record of what you're doing, at least can get your telemetry out of your Kubernetes managed Kubernetes infrastructure and into your logging a lot easier. And so that's one of the real things I say is a real benefit. Depending on your cloud, you have different resources. In AWS, it's called EKS, Elastic Kubernetes Service. Google, it's called the Google's Kubernetes engine, and in Azure, it's called the Azure Kubernetes service. They're all under the hood, Kubernetes. Their interactions are a little bit different, but we're going to be dealing with AWS for this lab. So we'll be looking at the AWS Elastic Kubernetes service. Microsoft created a threat matrix specifically for Kubernetes. Now, I'm a huge fan of MITRE ATT&CK. Have been since before it even got released. I love the approach. And even though not every little thing in there I agree with, it doesn't really matter. It's a good common language that you and I can have a conversation about that, particular attack technique. And we have a really great place to go and see the reference for it. Microsoft went and created something that looks very similar to the MITRE ATT&CK framework, but focusing on particular services, specifically on Kubernetes for this particular one. They have a container one as well. I think there's pros and cons with them doing this, but one of the things they do is they go into a little bit more detail about how you would actually implement an attack inside the environment. So you can kind of look at if an attacker is going to go and do something inside a Kubernetes environment, you can go and look at this matrix here, and you can just Google Microsoft Threat Matrix for Kubernetes. It's a pretty simple Google, it comes right up. And you can go and click on these, and it gives you some information about how you would perpetrate the attack. What we're highlighting here is everything you're going to do in just a minute inside your lab environment. We'll talk a little bit those in a second. All right, real quick, this is not a Kubernetes 101, but I want to hit a couple of things that are really important. First of all, I've got my control plane where if I'm running my own Kubernetes environment on a VM using Rancher or whatever it is, I'm responsible for implementing the control plane, right? It's on a VM that I control. I got to make sure it's patched. I got to make sure I put a username and password on it, which doesn't always happen. In our class, day 2, we actually start off with a story about a particular company. I won't spoil it, but it's Tesla, and how they had a Kubernetes cluster on the internet on an accident, obviously, and what the attacker was able to do inside of that environment because of that. But you move things into our managed service, and the AWS environment kind of manages this API cluster for us. So we don't have to do as much work to keep that managed. Now, in EKS, you're going to have things called worker nodes. These are the things that run a Docker container or whatever the container technology you're going to use. It's probably Docker, let's be honest. So we're going to run a Docker container on a virtual machine. You actually have the virtual machine inside your cloud environment. It's not serverless EKS, but it's stood up and it's built by the Azure API environment. I'm sorry, not the Azure. I did it. Azure and Amazon, they both start with A, and sometimes that trips me up. The Amazon environment builds and deploys that VM, and so you do have the ability to interact with it, but you don't really need to. It's kind of just part of the service that's built up. And as I'm talking, Ben's doing a great job of putting links in the Discord for you, so you can go and kind of click the links as I'm talking about. Thank you, Ben, for doing that. And strangely, I think there's 2 Bens. There's a real Ben. Oh, and there's Baker's channel. I see. That's what's okay. All right. So Kubernetes worker nodes can run on multiple different kinds of operating systems. The cloud provider usually picks kind of what that is. They deploy the runtime. They have the roles associated with it. And then you can manipulate and change it as you need for your environment. Kubernetes resources are managed through a command-let service that's running, and that kind of interacts with the worker nodes. The pod, now a pod is one or more containers. So that we're going to work together. So for instance, if I'm going to have a container that is like, I don't know, a front-end web service, right? And that front-end web service is going to have an API service always connected to it. I'll put them in the same pod so they're deployed together. And I can do some networking. So maybe the API service is never on the internet, but the front end is. Well, whatever it is. It's just, I'm kind of making this up. But I can deploy those 2 things together if I feel like it into a Kubernetes pod. They can be by themselves. It could be have more than one, whatever it is. And so I'll deploy those as a group into the Kubernetes environment. And then Kubernetes will be like, okay, I've got this pod. I've got to run it this many times. I'm going to deploy it to this virtual machine, and it's going to run in that virtual machine. And we're kind of hands off on that decision. We don't really have to do that. So there's a question, can this the lab be run in a different region? Not as it is, because it's using a VM, and the AMI is only in the region that we're discussing, which is US East 2, the Ohio region. Sorry. Yeah. I suppose there's a way you could move the AMI, et cetera, but I don't, yeah, I don't believe you can. So, once we get into our we're going to build our infrastructure in our environment. A couple of things about this infrastructure we're going to build. You're going to go into Cloud Shell, and you're going to run some commands. It's going to download an install script, and it's going to run the install script, and it's going to build a virtual machine. That is the simulator. That is the flight simulator. So this is an aviation themed set of workshops. And you're going to build your flight simulator. This flight simulator you can consider as your jump box. This is the thing that you're going to use to interact with your cloud environment. And that's kind of that jump box is what you're going to need your proxy for. The really cool thing about this jump box, which I just think is amazing, and Ben and Eric had built this, or I think Ben actually did it. So I just find it amazing. But it's running a web version of VS Code, and it has terminals built in the VS Code. So we will use the VS Code. We'll be able to look at a file in VS Code. We'll be able to run scripts in the terminal. It'll be awesome. Once you have built that VM, you're going to go into your VS Code. You're going to go into the terminal, and you're going to run another Docker another Terraform. That Terraform is going to actually build the EKS environment that we're working with. So once you've launched the Terraform, you can kind of chill out and come back. It should work. If for some reason you see a failure, just rerun the Terraform apply. Sometimes there's a timing issue. I think Ben fixed it, but some stuff happens, right? So just keep that in mind. Okay. I feel like that's probably it. Once we get that environment running, you're going to be able to interact with it. We're going to run some commands in the next lab. We're going to be able to run things like get caller identity. We're going to be able to list our clusters. We're going to do all this stuff, what you're seeing right here from the simulator. So that'll be our next step. All right. So I'm going to give this until, let's see what time it is. All my clock. Okay, we're gonna get this till 10:45 Eastern Standard Time. If you have any questions, reach out to Ben in the Discord. And then also, it says in the link, but Ben's highlighting, make sure you run your workshop updates to be able to make sure that you've got the latest and greatest on that AMI. All right. Okay. I will see you all in 22 minutes. See you then. So just a quick check-in with everybody. We are working on the lab right now. We're working on building our environment. If you have any questions about it, please reach out to Ben in the Discord channel. The link to get to Discord is on this URL that's on the page here, the aviata.cloud, and also the instructions for how to build the environment. So the question is, what is the link to the lab? If you go to the here, I'll show. I'll make it a little bit easier. So let me share the right screen here for us real quick. So this is our main page right here. If you scroll down, here's how you join our Discord channel, and then which is this channel right here. And then also right down here is the workshop agenda. We're on the getting started, build your environment. You would open that link, and it's the build instructions for everything. So if you scroll down, there's two different places where you're going to run a build. I'll walk through kind of what the build creates. But down here at the bottom, once you get down to here, you're going to run a Terraform apply. It works pretty much all the time, we think. So once you're done, you can come back, you consider done. It'll take about 20 minutes for the whole thing to build, but hopefully by the time I'm done talking about our next section, you'll be able to go in and run your labs. All right, see you in 15 minutes. All right, welcome back. A couple things, just highlighting some questions and stuff that happened in your lab. If you're still working, keep working. Ben's hanging out and can answer the questions if you have questions. These labs, you can just do them at your own time whenever you want. So it's not like you have to be finished by the time I start talking. There were some questions about how long that these labs will last. We're probably going to have this stuff online for, Ben said, like the rest of the year, probably longer. It's really just some GitHub code and an AMI. I don't want to say it's just, but the infrastructure is just an AMI and GitHub code. And so you're running it in your own infrastructure. So you get to be in charge of when you spin it up and when you spin it down. I do recommend you do spit it down when the lab is over. You can always recreate it and redo the labs as your own desire. But it does build some hefty VMs, so don't forget it when it's over. But these are your own accounts, and you have full control over them. So do them at your own risk. Let me. I'm not going to walk through the build because that would make any sense. I already did it. But I want to just highlight a couple things about what was created and kind of also just give you a little snapshot of the system itself. So let me see. Let me pull up the right one. I have a Mac and it's kind of weird. I have one big giant screen. It's hard for me to have multiple screens. It's kind of pain. I don't know. I think I like my Mac, but one of the things that I'm running in my my proxy right here. I'm sorry, I'm running in Firefox with my proxy installed. I've already gone through all of that. Here's all the instructions for installing Smart Proxy. This is the one that works reliably. There may be others, but this is the one we found that works really reliably. Also, Hayes, correct me if I'm wrong, but I think the next chapter of this workshop is Eric's. Is that right? I think because if it's Eric's, then you're going to be using this simulator again for doing a how to lock down your Kubernetes cluster. It's the exact same Kubernetes cluster. So we've got a few of these in the workshop rotation that all using this environment. So it'll be good to have it installed and ready for the next one. All right. So we're logging into our AWS account. However you log into your AWS account, we are making the assumption that you have full control over your AWS account. If you're using a corporately provided one, you might have limitations on what you can spin up, and that might cause problems. So you can get your own account with a credit card and email address. That's all you need. We're going to go into our shell, and we're going to create a directory. And then we're going to run this command right here, which is going to install. I know it says version chapter 3, but we are chapter 4. But we're going to install that and run the installer with this key right here, fly with K8s. And that is going to build a VM. So the VM that it's building is this one right here called the ACE 135 simulator, and then dash and then some words. So we can run this multiple times, and you'll have different versions of it if you desire. There's no real reason to do that, but you can. It is going to create an MX5 or M5X large. So when this is done, you can go and turn it off. The other thing you can do, if you don't want to destroy the entire infrastructure, you can always just stop the instances, and so then they won't execute. There's a question coming in for Q&A about having problems. Please jump on Discord because that is the best place for Ben to be able to help you with your technical questions. I'll have my Q&A open on Zoom if you want to ask like me questions while we're doing this talk. But you're using Discord. I've got Discord open, so I'm looking at Discord. And one thing I liked is if you go to the aviata.cloud page, which is let me find it, aviata.cloud. Right here, we have our getting started, which is our all of our instructions, and also right here for logging into AWS. But then right here is joining Discord, and Baker can answer. Hayes can answer all that. Okay. So we're going to create this simulator. And once we create the simulator, we're going to log in to the simulator using our proxy and pull up VS Code, which will look like this. And so I work for GitHub. We do a lot of VS Code. VS Code style is actually built into GitHub, so quite familiar with it. It's really cool that you can just run this on a VM like this. I had never done it. And so this is great. So I think the 540 class, SCC 545, 540, which is the automations. I forgot the name of the class. I'm sorry. It's changed a couple times, but they're running out of an infrastructure like this, which is pretty cool. So inside of here is where we're going to do the rest of our commands. Let me show you what the commands are. So once you get that, that's running Terraform. You'll also need to download, and we show you exactly how to download your proxy file, which is created for you, that you just have to pull into Smart Proxy. Super simple. Follow the steps. Ben did a great job of laying it all out. Then we log in. Here's our username and password into the simulator. Run workshop updates. Ben's put that out a couple times. It's actually linked in the channel. That you got to run that to make sure you get the latest. Open up a terminal and just clone and Terraform. Boom, done. And just kind of let it sit. If for some reason you get a Terraform failure, just hit the up key and rerun this. I think Ben figured out the problem, or at least got past it, but there was like some kind of weird timing issue that we were seeing earlier in the week, but I think it's going to work, but just to give you a heads up. All right, once you've done that, you're going to create our, well, you're not creating that. Let me go to what you created. That is kind of what you created. But what we really spun up is our EKS environment. Let me click the ads off. Oh my gosh, so many ads. All right, so I've got an EKS cluster that has been created. I can go and click into it and I can see the resources. I've got all this kind of information. There's some limitation to what I can see because of my because of the way Amazon does this identity access management. I can see very easily about the creation of the cluster, but getting into the cluster, I have to actually create a different kind of principal, and the one by default doesn't work, which is so weird to me, at least for me. Maybe you all, if you're logged in as root, maybe you don't have this problem, but I do for me. But what we're going to do is we're going to interact with this cluster through the command line is what we're going to do. Some other things that were created, just to kind of round this out. A VPCs was created for us. It's called Aviata.vpc, and also a VPC called ACE135 simulator. So our two VMs live in two different VPCs, and we had some CloudWatch logs. Now, we're assuming that you have some familiarity with AWS or Azure. I'll try and use kind of generic names for these things, but these are our logs. We have our flow logs, which are network logs. We also have our Route 53, which is DNS logs. And then we have CloudTrail, which is our API logs. And they're all sitting right here, ready for us to use to examine. All right. If you have questions and something's not working, please reach out to Ben on chat. Be happy to help. All right, let's see. And Hayes has been popping up links to Discord in the Zoom chat. So if you're not on the Discord yet, just look at the Zoom chat. You'll be able to see it. All right, let's move on to the goody stuff. All right. We are not going to go through every different way to attack a Kubernetes cluster. That's a great pen test conversation. But that's not what we're doing. We're going to talk about one kind of way to attack. And the intention is to generate the kind of logs that we need to do an investigation or a detection. And one of the ways that we can do it is by getting access to our Kubernetes environment. Now, initial attack vector. There are a lot of different ways in which we might have an initial attack vector into the Kubernetes environment. We are not trying to simulate a complete unknown attack against an account and gaining access. That's a long time thing to do. We don't have time in a workshop. Our goal is to get through the attack as efficiently as possible so that we can generate the kind of logs we need for a detection. This is a detection-based lab. However, I do want to talk through how initial attack vectors are inside, get access to our Kubernetes cluster. Now, if we were talking about a Kubernetes cluster that you have set up and managed yourself inside a VM, the very first thing I would say is make sure that the API is not on the internet or it has username and password that is locking down. That is the number one way. You can deploy a Kubernetes cluster without proper credentials. Maybe you think it's for a dev environment and then becomes prod. Anybody ever been in that world where like something was dev and you're like, oh, we'll just turn this off, and then suddenly it's making money for the company and now it's prod? Yeah, that happens more often than we would like. And so you're going to be able to you're going to have to kind of like understand that, that kind of stuff can happen on accident. So that would be the one way. That's not going to really happen if we're running our own AWS or Kubernetes cluster inside of Azure or the other clouds. They're providing the same identity access management protections as you do the rest of your cloud environment. So we're not looking so much at Kubernetes initial access vectors, but cloud initial access vectors. So how can an attacker gain access to cloud credentials? Leak through GitHub or VM images or files on host or some other ways. In our new environments of cloud, things are not using passwords as much. I have automation. I'm probably having a token of some kind. Tokens get released. If you have a long-term credential in your AWS environment, such as an identity access management user with access keys, those things are going to get released on accidentally. It happens. That's why those keys are terrible. We shouldn't be using them, but we do. But those keys and things can get released. And if they become released, people can go and grab them. So I've seen for a fact and like reports, there's this guy that was a developer. He actually checked his keys in. The news article said S3 keys, but they were like IAM user keys. He realized his mistake. He pulled them out. They were only in there for 15 minutes. He went and looked at his environment. He had all these VMs running from cryptos. They were just pulling things up. So, you got to watch out for those keys. Sometimes keys get pulled into VM images or Docker containers and get deployed to, Docker Hub or something like that. Keys accidentally get put into these environments. That's why we should be moving towards short-term credentials in all cases, but we're not always there. So keys is the biggest one. An attacker who may gain access to a private registry might then churn and put their own images in there. And those images could give them additional accesses. This doesn't happen a lot, but it has happened a couple times, especially if the attacker has gained access to a Docker Hub or some other kind of place. They can go in and plant their images. And then when you download them, not realizing that they're tainted, you suddenly can have maybe a backdoor. That's kind of the problem. There's a file which we'll talk about called the Kubernetes config file, kubefit-config. And that kube-config file has cluster info, and that file can be checked in to a Docker Hub or a GitHub or something like that. Your container that you're running itself could be vulnerable, and someone could exploit that application and turn that as a pivot point. Or as I kind of had the last one, which hopefully doesn't happen in an EKS environment, your Kubernetes dashboard could be on the internet. Now, we are going to assume, for the sake of brevity for this class or for this workshop, is that the attacker has gained some level of access to your AWS environment through one of the means that I was just showing you. Okay, so they're already in. We're not going to try and simulate that. We don't really want to put your account at risk, right? Which is the other thing. So they have gained access. You are going to be sitting on the simulator machine with access to the simulator machine that you have gotten to somehow. And what we're going to do is we're going to ask Amazon to create us what's called a Kubernetes config file. And what it's going to do is that config file is going to give you, for a certain amount of time, access to the Kubernetes cluster to administrate it. So that's kind of one of the nice things about AWS and Azure and these other services is that before you would have a long-term credential that was stored in a file. Now it's a short-term credential, but in order for the Kubernetes tooling to work, it's assuming there's a file. So Amazon is like, look, I'll just create you a file. It won't, the keys won't last very long, but I'll just create you the file. And so what we're going to do is we're going to go and ask Amazon for the config file, and they're going to create one, and we're going to download it locally. And now we can interact directly with the Kubernetes environment. Because we can interact with the Kubernetes environment, we are going to deploy our own pod, our own container. And that container is going to be a reverse shell. What we're going to do is we're going to have the reverse shell talk back to our simulator VM. Okay. So you're going to put the listener up on your VM. We have the instructions are all in the lab, so it's pretty easy. You're going to initiate the creation of the pod. It's going to call back. And then what's the biggest problem is not so much you have a reverse shell on a container, because like, that's not interesting. But a lot of times we have configuration of our EKS clusters or our Kubernetes clusters where we allow a couple things to happen that shouldn't. One is that we allow containers to run as root. We should not do that, but it happens most times. I mean, like what the last thing I was reading is like 70 something percent containers were running as root. So really bad, right? The other thing is that a Kubernetes cluster has to be able to interact with the virtual machine for some reason. So I'm going to pull up, your screen went black. That's because I'm going to draw. Okay. So just so you know, you're not losing your mind here. All right. So an Amazon, I'm sorry, we'll use this color. So a Docker image is a set of binary images. Like, so this is our basic Ubuntu. And then I'm going to install Nginx on it. That creates another layer, right? And then I'm going to install patches, let's say. So it creates another layer. And each of these layers is a diff. It's a binary diff of the one before. And then that is our Docker image. And now I'm going to say, hey, listen, Docker image, I want you to run. And when I run it, it creates another layer. And let's say in that Docker image, I have, I don't know, logs that are being created, or I need to go and pull from someplace on the host configuration file. So I need some interaction with the base host. Now, the nice thing about it is that when I stop my container, so the container's still there, it's just stopped, all of this stuff in yellow disappears. Like it doesn't retain any of that information. So this is where you're kind of ephemeral. You can spin it up, you can delete it. The stuff inside it is not, doesn't stay around. But we may want to be able to move logs, telemetry, other kinds of things into the host environment, the virtual machine that it's running on. And so we can mount to our environment. So we're allowing in this Kubernetes cluster to do mounting. What we're going to do is, as root, we're going to mount to the base operating system. All right. So the attacker is going to tell Kubernetes cluster, I need you to go and pull some information. So let me so there was a question. Let me hit that real second when I get to this. I'll tell you about how to double check to make sure everything's destroyed. So when you go and you're ready to deploy this pod, and this pod is going to basically have full control whatever we want it to do. We're also going to tell the Kubernetes cluster, go and pull from Docker Hub. So it's allowing me to just pull and deploy whatever I decide I want to pull. And that's happens in your environment. And this can be a danger because you don't really know what's being deployed inside your environment. Once we deployed our stuff inside environment, that pod, that container is going to call back to our attacker machine, and it's going to open up a reverse shell. That's going to give us basically console access to the container, which is not such a big deal, except for the fact that the container is mounted to the host. So I'm going to be able to pivot from the container to the host operating system in the virtual machine. So a couple of things you're going to see when you do this. You got a, let me pull up my pointer here. You are going to have a manifest that describes how to deploy the Kubernetes cluster. I'm sorry, the pod. And one of the things here is a Docker image, and that Docker image is Netcat. All right, so it's going to go pull this Netcat. We're going to provide how to mount it. I'm going to mount it to the host volume. That host volume is / basically the top level volume or the top of the virtual machine. I'm also going to provide some arguments. One of the arguments I'm going to provide is the IP address of the attacker machine. So this is your simulator. The communication is going to go from your account, from your virtual machine out to the internet and then back in. So we can see public IP addresses. We run that command by just doing Kubernetes TTL apply-f and then the name of the file. Now, this pod is going to communicate back to our host system. What we're going to do is we're going to run some commands, which will show you all the commands. And one of the commands is going to give us a really nice prompt. And then we're going to do a chroot. We're basically going to say, hey, listen, I want to map directly and change my root directory to be basically /host, which is / on the host system. And then from there, we can start running CLI commands, just like we were on the virtual machine. And one of the things we can do is say, hey, what are you allowed to do by getting my credentials? And then we're going to get credential information coming back. Once we get those credential information, we're going to say, hey, listen, I got this data. Can I do some things that the host machine can do? And apparently, this host machine is allowed to look at S3 buckets. And one of those S3 buckets has sensitive information about flight plans that are that we're going to be taking off in our solo flight that we're trying to protect. Now, that leads us to our lab. So what we'll do is we will do this lab until 11:30. Man, time is flying. So we'll go to 11:25. There was a question about how do I know if things are destroyed. So let me show you how to tell if things are destroyed. Let me pull that up. Let me share this. So if you go to your EC2s, there should be no virtual machines. So that's like the best way to tell. When you run your Terraform, it will fail if there's a failure with deleting, but you can go and see and delete these things. The other things that you're going to have is S3 buckets, which you're going to interact with all this stuff. So I probably have other S3 buckets in here that are not related to the class, and then our CloudWatch. So just go and look for those things. You should be able to find it. All right. Let's take ourselves till 11:25. And then I will walk through that section, and then we'll get us to the last part of the labs. All right. See you at 11:25. Hey, I just want to make sure everyone is on the same page on something. We're running this lab in our VS Code environment, the one that we set, not in Cloud Shell, not on your local system. You're running this environment from your simulator. So make sure you've logged into that. That's like the very last thing that you did when you ran the Terraform apply in the previous section. Just kind of stay in that in that VS Code environment. All right. Okay. All right. Welcome back. Let's do a little look at our lab here. So a couple questions. Oh, couple things. Yeah, I'll hit that in just a second. That's what I want. Okay. So we are inside of our cloud environment, and we're doing a couple things. First of all, our big one is to figure out is to get access to our Kubernetes cluster. And we can, well, first of all, we're going to ask a question. What is the name of my cluster? So AWS, make sure y'all can see this. Yeah. AWS EKS list clusters. And we only have one cluster. We could have gone through the GUI to get it, but we're trying to show some different ways of getting information about the environment. So the next thing I'm going to do is I'm going to update, which I've already done, but I'm going to run this command that gets my new Kubernetes cluster file. So now I have a file that will give me access to the Kubernetes cluster plane. So I always think about it this way is like in the cloud environment, there's like different planes. Like there's the management plane. So anything I'm interacting with storage accounts or like creating and deleting virtual machines, that's all the management plane. Then there's usually like a data plane. So like interacting with specific blobs on a storage account or an S3 bucket, that would be the data plane. This is almost like the Kubernetes plane. It's not really data plane, but it's not really, you're really kind of going into the Kubernetes cluster itself. You're not using the standard like AWS APIs. And so I need a file that lets my kubectl system work. So one of the questions was about like instance IDs and stuff like that. We can get a lot of information by running this kubectl who am I right here. And so I've got some information about like what is the role that I am using right now to interact with the environment. And that role is right here. It's actually the role applied to my simulator, right? So that's who I'm running as. So now we're going to interact. Now, I had a question about the metadata service and like why we did this. So in a virtual machine running in the cloud environment, it has to be able to ask questions about who it is. And one of those questions it can ask is, what is my ID? What's my IP address? Lots of stuff like that. And so what we're trying to show is a couple different ways and get information about your cloud environment if you're not used to it. So the metadata service is at 169.254.169.254. And it can give me some really good information like the ID. Now, I just saw the ID, but this is another way of doing it. So just ask your question. It's just to give you some different views of things. Also, we're going to need to leverage this when we get onto our attack machine. We're going to go and look at our credentials in the metadata service. But the metadata service can give us a lot of great information about my environment, such as things like my identity access management, my host name, my public IP addresses, et cetera, et cetera. All right. So we also had to then, I won't show you now because I already done it, but we have to open up port 9999. That is going to be our reverse shell port. So we've had a couple commands on doing that. We're going to go and get our public IP address. I'm actually using this metadata service to get my public IP address. And my public IP address right now, don't attack me, please, but my public IP address is 3.148.107.52. So I need this information to change the manifest that's going to specify, hey, when I deploy my reverse shell, who am I going to talk back to? And so where we do that is we've got this, and this is something Ben showed me how to do. I have this kind of file here. It's a template file, and I've got this, which is our variable. And I'm going to run a command called env substitute, which will take the old file, change out any of the variables, put the new variables in, and then output it to another file. So Ben, thanks for letting me know about that. And so we're going to do that, and that's going to create our reverse shell file. Okay. So now that's been created and it's proper, we're going to go and split and get two different sites here, which I'm stupid. I went, I kind of showed like the way to do that through here and split terminal, hit bash. I actually didn't see this icon that I could just do it right here. So I didn't see it on this one. Duh. Okay. So now what I'm going to do is I'm going to set up my listener. So my listener, I'm going to use Netcat. If Netcat is super fun, Sans 504 spends, well, at least it did when I took it, a lot of time looking at Netcats and making use of them. And so I'm going to set my listener up, and now it's listening for somebody to connect to it. Now what I'm going to do is I'm going to apply this manifest right here, which is something we looked at in the lab. And that hopefully, or not through the lab, the walkthrough will give me, hopefully in a second, yes, all right, I got connection. I'm assuming that's the right one. So I can run things like, who am I? Root, host name. Oh, that's the host name of the pod. So that is the host name of the pod that I'm on. What allows this attack to work? Host path? No. What allows this to work is that I can deploy a Kubernetes pod. I mean, for right now, what we're doing, I can deploy a Kubernetes pod to this Kubernetes service. So as we talked in the conversation, I've somehow gotten access to credentials that allows me to do something inside the environment. We're going to run some curl commands. One thing we can do is we can ask questions about my security credentials on this host. Oh, why didn't it come back? I am on. Oh, I know why I didn't do the rest of it. So I'm on the Kubernetes cluster right now. What I want to do is I want to change to the host itself. So I'm going to say, hey, change my root, my root to be /host. And because if you look up here, right here, /host mounts to / on the virtual machine. I'm going to give myself a much better prompt by using this handy dandy Python. And now I am on the host as root. It will print out what I just typed, which is kind of awkward, but I'm going to make my curl a little bit easier to read by using that handy dandy command. And now I can do things like go and get my credential information. And I am on the node itself now, which means I can do AWS S3LS. And I can get access. And I have other things here that aren't related to the lab, but I can see right here, I have access to my S3 buckets from a container that we deployed. Now, the reason this works is because of host path. We've had the host path. Now, if you're interested in locking this down, the next lab, chapter 5, I believe, we will go through how to do that. All right. So there's also some other stuff about stealing flight plans, but in the interest of time, I assume you can run those commands. If you're still working on it, please engage with Ben. He's happy to help. Let's talk about the next section, which is the detections, which is right. We're all here, hopefully. All right. Uh, okay. How do I detect something like this happens? Let me make a distinction. How do I detect is different than how do I do an investigation. Um, Someone deploying a pod in your environment, you probably will detect on accident. Unless you have like a really clear cut program for how you do deployments of your containers, or you're using some kind of service that evaluates all your images and makes sure that they're from a standard registry. That kind of stuff happens if you're like a financial industry or something like that, then you have requirements and you're probably more locked down. But for anybody else, you're probably letting your developers build, deploy, and operate, which is a faster process. And so you have a lot of different people deploying things. And so sometimes it can be hard. So detecting an investigation, you might need an alert or somebody to discover something. That's kind of prior. For this lab, I will be honest with you. It was my hope that I would use guard duty to detect the shenanigans happening. You have guard duty turned on. If guard duty detected your shenanigans here, I would be interested in knowing. Malicious IP caller is probably not the detection it's going to detect for this one because you're both in the same environment. But a container with a sensitive mount, I kind of figured would have been thrown an alert here. Privileged container, a container that's running as root, I thought would be thrown here. I had container with sensitive mount the first time I ran this lab, and then every other time the guard duty does not detect. So if guard duty detected this, please let me know. I would be interested in hearing if it detected or not. But you can just drop in the Discord to let me know. I don't know. Kind of wanted that. So other things that we might use to be able to detect that we have a problem in our environment. Are there pods that we weren't expecting? Is there traffic going to a location like port 9999 that we wouldn't have expected? Is there an if with crypto miner is probably the one that is most likely happen if someone has access to to do this. Do we have containers that are running super hot? Like in order to do that, we have to know what normal looks like and able to detect abnormal. And we don't always know what normal looks like in our environment. So once we figure out that there is a rogue pod, let's assume we've discovered that there's something weird going on. I need to be able to figure out, I want to know how they got in and then what did they do once they got in? So how they got in was going to help me drop things. What they did afterwards is something so that I can figure out what information did they steal. I see that Cedric says Cedric, you got the container with sensitive mount alert. Did anybody else get the alert? You got alert. Okay. You all got some alerts. I don't know why I didn't get the alerts. It happened like one time, and then when I ran the lab, it didn't happen. So weird. Okay. So it's not in the lab, but this alert is probably the kicker that you need to go and do something if you've got guard duty turned on. All right. So we got some stuff. You're going to run these in the lab environment itself. I just want to kind of highlight it. I've got this VPC flow logs. This is network flow logs. Okay. So I got network flow logs coming from both of our VPCs that we've got installed. And I can ask things like, hey, do I see, let's say I've already know something's kind of weird. Where did I see traffic coming from? Where is this thing going? The guard duty alert will tell you which pod it is. And I think tells you the IP address of the pod. So you can go and say, did this pod do anything? And so questions like printing out the ports, the destination ports, and telling me which one's in play. 123 is actually ICMP. 443 is normal because it's a web service. Oh, I'd never heard of this 15371. That doesn't sound like something I should have. Once I know that I've got a weird port, I can pivot and say, all right, what else happened on that port? Who did it talk to? Oh, I see a couple different communications. One is actually the container, the pod, and the other one is actually from the vantage point of the simulator itself. So you actually see both sides of the conversation. And then I can go even further. Who did it talk to? What was it doing? So I have network traffic. I also can get logs from the Kubernetes environment itself. And in the Kubernetes environment, I can ask questions like, hey, what was deployed? What was the image? What was the container name? What did it mount to? This gives me really great. I don't have to click, click, click. I can run these kind of commands through the query. The nice thing about running through the query is that when you write the report that describes what happens, you can use this in your report and people can go and recreate the queries. Where if you click, 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 you're going to have command lines you're going to have like snapshots. And then if you delete this, which you should, you're not going to be able to see anymore. So having the logs really help. In an investigation, your biggest sit in a cloud environment is your activity log. So what your management plane activity logs are. You're going to be moving back and forth between resource logs and CloudTrail all the time in investigation. CloudTrail is going to tell you what the person did with that rogue pod, and we'll be able to see that there's list objects and get objects, etc., inside that CloudTrail environment. Which is now your turn to do that. You're going to go and run through this lab. It's about 15 minutes, which gets us to about 11. Oh my gosh, I can't do the math. 11:55, and then I will finish up with a few more slides to kind of wrap it all up. If you would, please, you can, if you need to leave or leave early, please fill out the eval. We've got 3 simple questions. It's anonymous. We just want to know how things are going. If you have questions about this lab, please reach out to Ben, who's able to help and ask questions, which you're doing really great job in Discord. And I'll see you in 15 minutes. All right, let me do a quick just snapshot of what we did in that last section, and then I'll finish out the workshop. Just so you know, Ben's going to stick around in Discord, so if you're still working on it, you can ask questions for a while. I mean, he's not going to be here all day, but he'll be here until it starts slowing down. And of course, you always have access to this workshop and the materials in it anytime you want. Okay, a couple of things. First of all, some of you saw the guard duty alerts. I don't get them. I don't know why. I cannot figure it out. This is a thing that is a thing with guard duty. It might be just my account. I mean, I saw them once. I don't know. It might be that I saw them once. I disabled it. I re-enable it, and it's ignoring them. I can't answer the question, but I'm glad you're finding them because this is usually what my kickoff would be. So I have in CloudWatch a whole bunch of different log groups here. And so we're going to look at our flow logs. We're going to look at our CloudTrail and also the interactions with the Kubernetes cluster. So creating and changing will show up in there. So real quick, I'll just look, kind of log by log. Here's our flow logs. I'm going to look at everything where destination is not internal. So all my external IPs. I know because of some investigation in, the work book took longer, but my destination port is 9999, and I can go and say, all right, what do I see? What kind of content? I only want to print out the total number of communications per destination address. Flow logs, I don't usually want to see individual logs. I want to see groups of logs. I want to see counts. I want to see, the highest number, lowest number, stuff like that. And so I can see that this IP address, now it's our IP address, but I can go investigate. Who is this? How am I talking? I can pivot. I can say, who else did this IP address talk to? Because it may not just be this one pod. It might be other things. So I have VPC flow logs. I also have my Kubernetes logs. And so I know that someone created a pod. Maybe the thing that kicked this all off is me identifying this weird pod that had been created. And so I can go and say, hey, look to see who did a create. And anywhere in the message, there's the numbers 9999. So there's other ways that I could narrow this down, but in the effort to be a little bit faster, I can say, all right, here is a tremendous amount of data. And because that data is JSON, CloudWatch is able to understand it and extract it. I have all these things that I can query on. And of course, in the lab, we show you how to pull out just the things that you need in order to be able to answer certain questions. I like doing this. I'll get this big thing. I'll figure out what the problems are and then try and recraft the query only to pull out what I really want, which is like my image ID, rename them so that when I run it, I have something really nice and clean that I can snapshot and put in my investigation documentation. And then the last log we looked at was our CloudTrail logs. This is all of our activity logs. I can ask a question. Hey, listen, anywhere that we had anything that had to do with the pod itself, that is not the pod, but the virtual machine itself. Now, remember, I'm not on the virtual machine running the commands. I'm in my inspector works. I'm on the pod, but I'm doing that from my simulator. So I'm through the simulator using that, and I'm just looking for activity, and I can see my get objects, my list objects, etc. So quick walkthrough of that lab just to kind of show you the screens. If you haven't finished, please, you can take the time to run through them. But I need to wrap this up in order to get you out of here on time. First of all, we're going to be moving more and more into the cloud. The way we protect our cloud environment is different than the way we did things on-prem. So I need to be able to rethink that. I need to know where my logs are. I need to know how long they're going to live in that environment. I need to be able to touch the owners of resources. So whoever that owns that cluster, I need to be able to say, hey, listen, does this pod look weird to you? And be able to understand from that, because I probably don't know everything that's deployed in my environment. There is a cloud exchange that is coming up. I will be part of the cloud exchange, and so will Microsoft, Amazon, and Google. This is like the only place I think where all three of the major cloud vendors get together and do presentations and papers and stuff. So you can go and register. It's completely free. Go and do that. The other thing is, for this lab, there's other labs that are coming up, other workshops. So please go and take a look at those future ones there and past ones as well. They're all great, and they're all part of this Aviata Cloud Solo Championship. The other thing is for cleanup. If you go into your lab workbooks, there's some cleanup instructions. It's basically run Terraform inside of your simulator, and then go back to your Cloud Shell and run Terraform destroy, I should say, and that will destroy your environment. All right. Well, thank you for joining me for this past couple hours. I want to say special shout out to Ben for helping us out with the labs and also doing all this back end stuff that allowed this to run so smoothly. Thank you, Ben, so much for that. I want to thank you for Hayes, who's been asking questions. Yes, you can get access to the previous workshops. If you go to that URL right there, you will get them. They're all cloud-based. They all have different aspects of the cloud, and there's could be one for almost every month of the year, I think. So, all right, have a great one and take it easy, and hopefully see you around a SANS class someday.